In this video, we're going to learn how to keep a selection and perform functions, union, intersection, and difference. Sets are a simple way to intersect lists of records from a single table. They're one of the ways you can use to put a selection on hold so that it can be used again later on. By performing an operation on two sets, we get a new set containing the result of the operation performed according to conventional set theory. We're going to apply these principles right away to the list of interventions in the navigation form. We can create a set from the current selection. We're going to create a button that searches for all the interventions that were started before 9 a.m. Here's the method of the button. Query interventions, interventions, intervention time. And we're going to create a second button that will give us all the interventions that are not yet 100% complete. We can program this button as follows. Query, interventions, intervention, progress less than 100. For the moment, in the file we imported, the progress percentage is not filled in. So first we're going to apply a formula on all the interventions. Here we have a selection of 11,732 interventions where we're going to apply a formula and specify that progress is equal to the rounded off value returned by round of the remainder calculated with mod of random, which returns a value from 0 to 32,767, the mod per 100 rounded off to the nearest tenth. If we now produce a report to check what progress percentage values have been filled in, we see that they range from 0 to 100. Of course, if we click on the first button and then on the second, we will have lost the selection created during the first click. So on the first button, it may be useful after the query to keep the information in a set that we can call morning interventions. Create set, interventions, morning interventions. Similarly, here, after retrieving the set of interventions that have not yet been completed, we can call the set interventions in progress. Create set, interventions, interventions in progress. Then we can compare the sets by adding them together to obtain the set of morning interventions and interventions in progress. We duplicate the button and indicate that these are the interventions before 9 a.m. and those still in progress. Then we can just write union, morning interventions, interventions in progress, interventions result. In a third set, call interventions result so as not to overwrite the first two sets. If we want morning interventions that are still in progress, we have to compare the common part of both sets so that we get all the morning interventions that are still underway. In this case, the command to use is not union, but intersection. And if we want to get completed interventions, we need to apply difference to the two sets. All the morning interventions minus the ones still in progress will give us the resulting set. We can test these different possibilities by executing the navigation form. We take all the interventions, there are 11,732, and here, after clicking on the query buttons, we still have 11,732. Why is that? Remember that in the previous video, in the navigation function we added at the very bottom, this line gives us the number of records found after a new selection is created. V number of records equals records in selection interventions. We're going to copy this code and apply it to the two query buttons. Currently, we do not have the table pointer here. We're going to process the interventions. Then we can copy this line of code for 4 other buttons. The union, we see that on these 3 buttons something is missing. The intersection, on the difference, and also here on the query button. Now if we go back to the navigation form, we have 631 interventions before 9 a.m., 11,192 interventions that are not yet finished. Interventions before 9 a.m. and those at 100%, 9 a.m. interventions still in progress, or 9 a.m. interventions that are finished, don't seem to change the number that is here. Why is that? It's because simply creating a set does not imply its use. In this button here, after we've created the union that creates a third set, we must indicate the particular set that needs to be used. So we're going to modify the code, and here we use the useSet command. Copy, then we're going to put it in the other 2 buttons. So we add the line for the set to use in the other 2 buttons. And that way we can test interventions in progress. We have 601. Completed interventions, we have 30, which corresponds to the interventions before 9 a.m., in other words, 631. To complete this approach, we're going to close the form and launch the navigation method again to check its operation. If we click on one of the 3 buttons to the right, an error message indicates that the sets do not exist. Naturally, the sets must exist before we can use them. We're going to trace the creation of these sets by clicking on the first query button. We can see in the list on the left the sets theme that shows the list of existing sets in the process being traced. Currently, there are none. When the method is executed, we name the first set. Then we're going to name a second one while executing this one. Using trace mode, this will allow us to see the creation of the third set when the first line is executed. And then we'll see, because the set already exists, it's only the quantity that changes. You need to keep in mind that a set is only a list of records that is not necessarily the current selection, since right now the current selection of the interventions table contains 601 records. When we switch to the useSet command, the selection now contains a number of records matching the number indicated in the set, and the vNumRecords variable is also adapted accordingly. Another use of sets that is very convenient consists of selecting a certain number of records and then indicating that we want to make them the current selection. In other words, when we click the button, there are now only these X records. To do this, we must program the button, indicate that we want a selection, copy an entry in the method, and write the corresponding code. The code looks like this. In other words, we're going to create a set name, such as a text part plus the conversion into text of the milliseconds, get the highlighted records, like those that were clicked in the table in question, and create the corresponding set. Use this set, Recalculate the number of records to which this responds, then clear the set so as to free up memory. We can test all the interventions. We can select a few of them. And we draw the selection button. At this level, we have a set name. The set will be created here, so we have 3 items in this set. We'll use it so that it becomes the current selection of the interventions table. We'll recalculate the number of records, then we'll clear the set. In our array, we now have the list of records that we selected. A set is made up of 1 bit per record and therefore does not preserve the sort order. When you need to keep this information, you must use commands related to named selections, copy named selection, and use named selection. Here, we're going to add a button that allows us to create a first selection, T1 named selection. We'll copy the code into the named selection. And duplicate the button, T2. It's now possible to store 2 selections that will take the sorting order into account. They exist in memory, but will not be used. Then we're going to duplicate these buttons and modify their formula to request the use of these selections. Here we don't need to specify the table. If we take all the interventions, let's take the first ones, selection, sort them by date and time of intervention, create a first selection, then take the same selection, we'll sort it by object and intervention time, and then we create the second selection. Now if we call back the first selection, it comes sorted according to the criteria indicated, date and time. If we click on the second button, they're sorted as we requested, first by object and then by date.